Welcome into this tutorial of Proflan YouTube channel. In this particular video, we have to look at the kind of questions that have been asked in Gcse physics so that you can be able to prepare for that exam. So if you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. So I want us to dive in so that we can be able to get started on the first question we are going to look at. In this question here, we are told that the figure shows a bat and its prey. The bat emits high frequency sound and pulse to locate its prey. The speed of the sound in air is given as 330 meters per second, and the frequency, we are supposed to calculate the frequency of the sound, and the formula that connects that is V is equals to F lambda. So something that you need to take into consideration, we are finding F, so we can be able to rearrange this equation here, and this becomes what? The equation becomes F is equals to V over lambda. Lambda is given here, so which means we have to divide this by 1000 so that we can be able to have the wavelength in meters, and that is going to be 0.011. Then we can be able now to say frequency is going to be 330, which is our velocity or speed, divided by 0.011. So if you are going to work that, you need to put that in the calculator for you to work out the answer. Let's just put it in. It will be 330 divided by 0.011. If you work it out, you're going to get it as 30,000 hertz. This is 30,000 hertz. Yeah, so this becomes the frequency. So the pulse return to the bat after 18 milliseconds. Calculate the distance. Remember, speed is equals to distance over time, and this, the way this the pulse travel, it reaches the prey and then it travels back. So in order for us to work out this, we have to say twice the distance, because the speed will travel and then come back. So that is going to be 330 is equals to, because the speed was 330 meters per second, twice the distance over the time taken, which is 18 milliseconds. 18 milliseconds, this one also we have to convert it to seconds. Milli is the same as 10 raised to power negative 3, so we can divide by what? 1000 here. And if you work it out, you're going to get 0.018. So meaning that if we put here 0.018, then it will mean that for us to work out this, our distance is going to be equals to 330 times 0.08 divided by 2. I've multiplied this both sides so that I can be able to remove it from the denominator, and then I've divided by 2 so that I can remain with B. So we can be able to work it out and say this is 330 times 0.018. 0.018. Let me just change this. 0.018, yeah, divide by 2, which becomes 2.97 meters. The distance is 2.97 meters. So that's the distance between the bat and the prey. I think this pen that I'm having here now is finished up. we can be able to get a different one so that we can be able to continue. So we have a gentleman who kicked the ball from this end. It hits it at that given point, then it bounced back. So we are supposed to work out, in this question we are supposed to work out the height at which the ball hits the wall, because this guy hits this ball, it travels, it hits at a given point, then it falls back. So how can we be able to calculate that particular height? So we're going to use this formula here that say gravitational potential energy is equals to mass times gravity times the height. Then we are given the mass here. This is the mass. In this question we're given here energy, GPE is given here 11 joules, and then we are supposed to find H. In order to work out that, we're going to substitute into the formula, and we're going to say is 11 joules is equals to the mass, which is 0.42 times gravity is 9 point, gravity is given as 10, it's given here, then times the height. So which means this is going to be 11 is equals to 4.2 h divided by 4.2 divided by 4.2. Our height is going to be 11 over 4.2. So if you work it out, so you're going to say 11 divided by 4.2, that is going to translate to 2.2 2.6 meters, because each of the values here was given correct to two significant figures, so we are going to stick and give our final answer to two significant figures. And calculate the kinetic energy of the ball when it's moving at a velocity of this. Kinetic energy is the energy possessed by an object that is in motion. So in that case, we are going to say, using this formula that was provided at this given point, we can say this is a half times the mass. The mass was given here, which is 0.42 times the velocity squared. Velocity or speed is 12, so we are going to say 12 squared. Then if we put that in our calculator, we are going to 0.5 times 0.42 times 12 squared, which is going to translate to 30.24. 30.24, and we shall just transfer it down here just to make the examiner happy. 30.24 joules. That is the kinetic energy of this particular object. The next question also we are going to look at, which is a scalar quantity. I need to define a scalar quantity. A scalar quantity, yes, a scalar quantity. Those how do we define scalar quantities? I'm trying to work with something that is not working down here. Okay. Scalar quantities are those quantities which can be only described by size. They don't have direction. But vector quantities are described by both size and what? Direction. So in this case, acceleration is a vector quantity, force is a vector quantity, weight is a type of force which is a vector quantity. So we are going to say distance is a scalar quantity. A student has cupcake cases. So one cupcake case shown here. The student drops a stack of cupcake cases with the base facing downwards as shown here. The speed of the falling stack depends on the number of cases in the stack. So first we need to identify that there is a force pulling this down, and this is actually weight. Weight is pulling this down, and the upward force is called air resistance. Yeah, so those are the forces which are involved. So meaning if we have more cases, it means that there will be greater force acting downward, then this object is going to accelerate faster towards the ground, and that is why it's going to have a higher speed when we have more cases stuck together.